So now I know these aren't the graphs, but I want to use these as sort of guidelines here. Look at the degrees of these two graphs. They have degrees of 5, right? I know those are not what the graphs look like. They look something like that, but I know that's not the exact graph, okay? And then look at the degrees of these two. They have degrees of 6, okay? You also know from grade 11 math that if you have a quadratic, we'll just start with the basic quadratic. What does that look like? Parabola facing up. Boo. If I drew this, it's a parabola that's been flipped down, right? Okay. What do you notice about the degrees of these two functions? They are even. Okay. If you have an even degree function that has a positive leading coefficient, in this case 1, in this case 1, both arms are up. Okay? If you have an odd degree function, 5, -5, the arms go in different directions. Okay? All right? Now, the negative, obviously a negative, if we look at the quadratic version, a negative means they face down. Okay? Because both arms are in the same direction and they both face down. The odd, the thing you need to remember is if you have a negative leading coefficient, the right arm will always be down. Okay? In any case, actually, if you have a negative leading coefficient, the right arm is always down. Okay? So, if the graph of a polynomial function has two rising arms, so it looks like that, then the degree is what? Even or odd? And the leading coefficient is? Okay? If the right arm's up, it's a positive leading coefficient. If it has two falling arms, so it looks like this, the degree is? Even but negative leading coefficient. If you have a right arm that is up and a left arm that is down or falling, so they're going in different directions, is the degree even or odd? Odd. It has to be odd. If one is going in one direction and one is going the other direction, so if it looks like this, that's what that's saying. It has an odd degree, but the leading coefficient is positive because the right arm is up. And conversely, the right arm is falling and the left arm is rising, so it looks like this. It has to be odd and negative leading. So if the leading coefficient is positive, then the right arm is rising. The right arm is up. And if the leading coefficient is negative, the left arm is up. Either like that or like that. That's positive. And if they're negative, right arm's down. All right. Is that okay? You need to know those. Like you just need to know them. Or write them on your sticky note. But knowing them is better. Yes?
For x-intercepts, we said that the leading coefficient is negative.
Oh, sorry. Did I say left arm?
Yeah.
Oh, right arm is falling. Sorry. There you go. Probably fix that. That would be better. All right. The right arm is falling. Sorry, my mistake. All right. Is that okay? Now that we fixed that one glaring error. All right. So theoretically, what we could do, and by theoretical, I mean you should know how to do this. You can write this, I don't know, write it anywhere. Write it on the answer sheet. I'll do my question on the answer sheet. So if I gave you this, x plus 2, x minus 3, x plus 5. And I said sketch that graph. What is the degree of this polynomial? It's odd, right? Because this is what we did right at the beginning of the class, or this unit. X times x times x would be x cubed. So this is a degree that is 3, or odd. What's the leading coefficient? Positive or negative? Positive. So I'll just write LC for leading coefficient is positive. So degree is 3, which means the arms go in same direction or different directions? Different directions. And the leading coefficient is positive, which means the right arm has to be rising or up. Okay. Mark your x-intercepts. What are my x-intercepts? -2, +3, and -5. Everybody agree with that? The right arm has to be up, so we have to finish up here. That which means the left arm has to be down. You have to go through those points. So there's the graph.
Do we care about the y-intercept?
That's what we're going to do right now. So the y-intercept is a way to check to see if you drew the graph correctly. Okay? Y-intercept is what? When x is 0. So if you do the y-intercept when x is 0, I put 0 in there. I'm really just going 2 times -3 times 5. What's 2 times -3 times 5? -30. Does that answer make sense? What? Don't say sure. Why does it make sense? Yes, because it's down here, which are the negative numbers. If I drew the graph wrong and I drew with the y-intercept up there, that wouldn't make any sense because those are the positive numbers. Okay, so the fact that it's -30, it makes sense visually. All right, is that okay? All right, let's try another one. Sketch this. That's a negative right at the very front. Sketch that graph, please. And I'm going to freeze it. Are we ready? Boom. Is that it? Or something like that? Degree is 4 because it's x times x times x times x. So that'd be x to the power of 4. Leading coefficient is negative. Tiny little negative sign out the front there. So if the degree is even, both arms are in the same direction. The fact that we have a negative leading coefficient means they face down. Yeah, they can. Who got it right? Look at all those people.
I just had a pen.
Just a corner. Doesn't know what they're doing. Both arms face down. You mark the X-intercepts. You just start with the left. It has to be down. You just follow. They have to go through each one.
Isn't it -30?
Nope. Because why is it not -30? Because of the negative leading coefficient. You have to factor that in too.
Oh.
All right. And that's the check, right? Because if you got -30, you'd be like, what's going on here? But the negatives cancel and you get +30. All right. Do we feel okay with that? Negative. Negative VE. That's my lazy way to write negative. Okay. We're good? We're good? I'm going to stop this recording. And then we're going to move on to the next lesson.